Welcome back, guys. By now we are familiar with what is tree set, and we have seen that I have, in whatever example I have covered, I have shown you how hash set works, how linked hash set work, and how tree set works. But there is one example which we have seen earlier where when we were trying to store a custom object in the tree set, it was failing, right? It was failing. I will show you. So again, you have a custom object called person tree set. It has two field, which is private name and private age. This is nothing but your bean class, object class, where it will hold the data for your object, and this is the constructor through which it is getting sliced. Then there is a getter and setter, and then we are overriding the toString method to print the data of the object. Now in the main method, I am making the object of tree set, and what I will do, I will try to store the data. So I will do add method, and then here I need to make the object of the person's class name. Let's say I will write test1, and or I will write as cc, and age I will write, let's say, 40. Okay, so I'm writing like this, and then I will insert one more record and then one more. So here I will write dd, and here I will write aa, here 20, and here 30. So here what happens, if I will simply go and run the program, and then I will just write one print statement. So in the print statement, what I will do is I will simply print the object, right? Let's see that what happens in this case. When you add a custom object in the tree set, you will get classed cast exception. You are getting that classed cast exceptions because the problem is, as you know, by definition, tree set maintains the data in ascending order. Okay, tree set maintains the data in ascending order, and tree set will expect the data of type comparable. It will expect the data of type comparable or comparator. That both will work fine. Okay, it will expect. So what happens when you, in the tree set, when you store integer, string, and other primitive instance variable and primitive data type, like any wrapper classes, I am trying to say that any wrapper classes, when you store integer or string. So let's say when you store integer, you know that in collections we always store integer, or when you store actually a string. So basically what happens, when you go inside these classes, press Ctrl, click on integer, these all classes implements comparable interface. So these all classes are of type comparable, right? And this comparable and comparator I have covered in very details in my previous video. So this type is comparable. Now you go to the string also. A string is also a type of comparable. So that is the reason when you store any other data type, integer, double, short, long, and comparable, okay, you will not see this problem. Okay, if I write float also, f, and if I will go inside, see, this is also of type comparable. So internally this will work fine, because what happens, your tree set expects the data of type comparable always. So you can see that it expects the data of type comparable. So in that case, what I have to do, right? In that case, wherever you are going to store custom object in your tree set, you should implement comparable interface. Okay, you should implement comparable interface. What type? Comparable interface of the type your custom object, because you are implementing the comparable interface for this object. So comparable interface, if you go inside the comparable interface, it has a method, one method called compare to. It has one method called compare to, which will take object as an argument. T means the type of object you are going to compare. Type of object you are going to compare, which means you are going to compare person tree set type object. Now you place mouse over here, click on add unimplemented method. When you do that, you can see that automatically one method will overridden here. I will bring this up. Yeah, so you can see that one method got overridden here, compare to. Okay, now once this method got overridden here, you can write the logic here, right? You can write the logic here. you can write on what basis you want to compare. So you can do one thing. Let's say I want to compare on the basis of name or on the basis of age. So name on the basis of, I want to compare on the basis of name, so do name dot compare to, okay, and then this name, your this object name, whatever you are going to store, should be compared with this object. Okay, so whatever object is already present, so then you can do that o dot name. Okay, o dot, you can do that get name, because on this object we have a getter and setter. So basically how this will work is, okay, it will compare the object. So whenever what will happen whenever you will store any data. So let's say this record is already present, first record you have added, you are going to add one more record, this record. So when you are going to add second object, what will happen is, when you add the second object, this data will get initialized, name and age. Whenever you will add the record, basically you are creating the object of person tree set, so this data will get initialized. Now automatic, this comparative method will get called because it is of type now comparable, and you are comparing the name. So whatever already present, name is already present because of this, because this was the first object, name is already present in the object. When you are adding one more, it will go and it will compare with the existing one, and it will try to compare it, like whatever is present already and whatever you are adding it, right, both it will get compared. Now if you look at, if I run this program, now we are not seeing any issue and it is working fine. And you can see that now tree set is getting data in the ascending order. See, A came first, then CC came, and then DD came. But how we were storing that? CC DD A, but the output is coming is opposite, right? So you got it. Wherever you are adding a custom object, your class should be of type comparable, right? Your class should be of type comparable always. If you don't have that, then you will get a problem. Guys, you can see that we are able to store the custom object of type comparable. Now how we can store the data of type comparator? So comparator, there is not a straightforward way, we have a different way, and we need to write a different implementations for the comparable object. Okay, let's say I want to store the data in the tree set of type comparator, then how I will do that, right? I will show you in the next example. Here we are clear that you can always store a custom object, but you make sure that your custom object should be of type comparable. Yes, you can store the type of comparator also, but there is a different way, which we'll see that in the next example. And that is the reason when we try adding earlier the custom object in the tree set, it was failing, class cast exceptions. It was saying that your class is not a type of comparable. Okay, so with this I'll close the video. In next video I will talk about how you can store comparator type of data in your tree set. Thank you guys, thank you for watching this.